All right, so we're going to go over the answers to yesterday's worksheet, calculating time of death using Algor Mortis. So the first one, you were given a situation where a body was found and the temperature of that body was 33.1 degrees Celsius. So what we're going to do is we're going to start like every other problem. We're going to do 37 degrees Celsius minus the 33.1. And what are we going to get? 3.9 degrees Celsius is the temperature lost. So that temperature lost needs to be compared to our, like, how much temperature can be lost at 12 hours number. So we're going to say, is 3.9 degrees Celsius greater than or less than 9.36? Less than. So if it's less than 9.36, then that means it was less than 12 hours ago. And that means we're going to use that example from our notes. So what we need to do is we're going to take our 3.9 degrees Celsius and we're going to divide it by the rate for the first 12 hours, which was 0.78 degrees Celsius per hour. And what did you get? 5 hours ago. Awesome. So 5 hours ago would be the correct answer for number 1. All right, so let's look at number 2. Number 2 actually didn't require you to do any math. What number 2 wanted you to talk about is if the body was found outside in winter, what would that do to this rate of cooling of the body? And so because it's colder outside, it would cause the body to cool down faster. So it would have been a shorter time than the calculation that we did above. And we would say because we have to explain our answer, the body would cool faster in a cold environment. And the principle is the same. Like, I mean, we put stuff in the refrigerator to cool it down faster. A lot of like the baking shows, everybody puts things in the freezer to get it to cool down fast enough. But the same situation applies for a body. All right, so now number 3 gives us another temperature. This time it's 25.9 degrees. So if we have 37 degrees Celsius minus 25.9 degrees Celsius, what did we get? I don't have my 11.1. So 11.1 degrees Celsius was our temperature lost. Is that greater than or less than 9.36? It would be greater than 9.36. So that means it was more than 12 hours ago. So this example, we have to do a little bit differently. We need to use the 9.36 to find out how much temperature was lost after the first 12 hours. And so what does this end up being? 4.74, you said? 1.74, sorry. All right, so 1.74, and then we can take our 1.74 and we're going to divide it by the rate of cooling for the after the first 12 hours, which drops down to 0.39 degrees Celsius per hour. And what did we get here? 4.46 hours ago. But am I done? I took out the temperature lost for the first 12 hours. Now I have to put those first 12 hours back and get 16.46 hours ago as my answer. All right, so then we're going to look at number 4. So number 4, this time the body is really cold. We're looking at 15.6 degrees Celsius. So if we do 37 degrees Celsius minus that, what are we getting now? 21.4 degrees Celsius is the temperature lost. Is that greater than or less than 9.36? It would be greater than, so this is definitely more than 12 hours ago. If it got this cold, we would say it was probably in like a refrigerator or something. Like there's a condition going on. Room temperature in Celsius is about 25 degrees. So this is cold. So let's see. If we have 9.36 needs to be taken away for the first 12 hours of cooling. Now what do we have? What do we have? 12 point, am I losing my mind? 0.04, okay. And we need to divide by the rate of cooling for after the first 12 hours, which is 0.39 degrees Celsius per hour. And we get that is 30.9 hours. So we got to add the first 12 hours back in. And now we have 42.9 hours ago is our answer. Let me move that up so I can circle it. 42.9. So is this seeming pretty straightforward so far? All right. So now we have like a refrigerated body for sure on number 5, 10 degrees Celsius. So if I take my 37 degrees Celsius minus 10, so 27 degrees Celsius is the temperature lost. That is definitely greater than 9.36. So it's more than 12 hours ago. So what I need to do, take my 27 degrees Celsius, going to divide by the rate for after the first 12 hours. And what does that one give me? Yes, good. Okay, so we need to fix this. So when you get in a hurry, did that happen to you on any of yours? Anybody fess up? Did you do that? So a lot of times on the test, I see that people forget to take away the first 12 hours. So if we take the 27 degrees Celsius, you're supposed to take away that 9.36. And what do we get? 17.64. Okay. So we got 17.64. Now we can divide by the rate of 0.39 degrees Celsius per hour. And what do we get? I think I'm getting 45.2. Is that what you got? 45.2. Am I done? Nope. I have to add back in the first 12 hours. So now I'm looking at 57.2 hours ago as the right answer. Is that better? All right, so let's see. Now we have number 6. The body has cooled down to 29.4. So 37 degrees Celsius minus 29.4. We got 7.6 degrees Celsius lost. Is that greater than or less than 9.36? It is less than 9.36 degrees Celsius. So this is a less than 12 hours problem. So we're not going to do that extra step that we were doing in the other question. So this time we do put 7.6 degrees Celsius and go straight to dividing it by the rate. But we have to use the rate that goes with the first 12 hours, which is 0.78 degrees Celsius per hour. And what does that come out to be? Do you get 9.74? So we got, okay. 9.74 hours ago. All right, so if we're flipping it over, now we're on the last one that requires math. We're on number 7. And the body in number 7 was found at 24 degrees. So we're going to take our 37 degrees Celsius minus 34, or not 34, 24. Sorry. Getting ahead of myself here. And we get 13 degrees Celsius was lost. That's greater than 9.36. So we have to do the more than 12 hours example. So what is the step I need to remember? Yep, I have to subtract the temperature lost in the first 12 hours, which is 9.36 degrees Celsius. So minus 9.36, we get 4.68 degrees Celsius was lost after the first 12 hours. So I'm going to take 4.68. I'm going to divide by 0.39 degrees Celsius per hour. And I got 12. Is that what you all got? All right. Am I done? Did I do something wrong on the math? Everybody's looking at me like I did something weird. 9.33. Okay, let me try that again. I got distracted by the door opening. 13 minus. Because this is not the right number over here. This is what happened. All right, so this should be 3.64. That's where it went wrong. All right, so 3.64 divided by that rate is 9.33 is what you said? Awesome. But am I done? Nope, I have to add the first 12 hours back in. And now we have 21.33 hours ago is our answer for number 7. All right, so part B has us looking at what would these conditions do to our estimate. So part B does not actually require you to do any math. We are just looking for what would these conditions do to the rate of cooling. So if the body was found without clothes on, would that speed up or slow down the cooling of the body? It would speed it up, right? So it speeds up the cooling. So what would that do to the 10-hour estimate that the investigator had? Would it be more than 10 hours or less than 10 hours? It would be less than 10 hours. So it would be a reduction. So it would reduce the 10-hour estimate. So why do you think the body not having clothes on speeds up the cooling? What do clothes do for you? They keep you warm. They like hold in your own body heat. Like they don't do anything other than trap that heat. So clothing is an insulator, or you can say clothing traps heat would be a good way of explaining that. All right, so what about our next one where we had the wind? What would the wind do to the cooling of the body? Speed it up or slow it down? Speeds it up. So if we're speeding up the cooling of the body with the wind, it's the air is moving the warmth coming off the body away. So the more that heat that's coming off of the body is moved away, more heat comes out, and it's going to accelerate that. So we are again going to reduce the 10-hour estimate. I'm doing EST for estimate because I'm not liking writing this much. All right, so next one. If you had an illness before death, what would that do to your body temperature? We're getting checked for it every day on our way into school. Fever. If you had a fever, what would that do to our calculations? If we're trying to, like, we didn't get to measure the person's temperature before they died, we're just measuring it after the fact and comparing it to a normal temperature. So if they had a fever, they've actually cooled down more than we thought. So what would this do to our 10-hour estimate? It would actually increase the 10-hour estimate because we had more temperature to lose. All right, finally, our last one is if we had a body submerged in a lake. So lake water, how is it usually compared to the air? How's it usually feel? It feels cooler. So back in biology class, do you remember talking about like water's heat capacity? So water is resistant to changing temperature. It takes more energy to warm up water than it takes to warm up the air. So the lake is generally cooler than the air. So we're going to say it's cooler than the air. So that means that the body would cool down faster because that water would be removing the heat more than the air would. So that would reduce the 10-hour estimate again. All right. So once you have checked your answers, if you did not yet submit in class, people, make sure you submit your worksheet for today. And then we're going to use the rest of today as a catch up. So if there's anything that you need to take care of, please do so. And I'm going to stop our recording.